It seems to me quite a few people are worried about sea level rise in 100 years, but what about now? Welcome to Distilled Research. I'm Dr. Kyle Grokowski. In this episode, we are looking at sea level rise over the past 10 years. This topic touches on coastal businesses, living on the coast. Man, I wish I lived on the coast. You know, when I retire, I'm going to get this sweet cabin on Lake Michigan and just chill all day. Anyways, this work was done by Krista, Jankowski, and colleagues at Tulane University, resulting in their paper published in 2017 by Nature Communications. I'm interested in this paper for one main reason. This is not a prediction, but a trend measurement of current day sea level rise. I will always trust a measurement now over future predictions. First, let's set up the problem. You have coastline, you have the sea, and you have the wetlands. The measurements you'll need are twofold. You need to measure the amount of new sand and dirt deposited onto the coastline. This is done with a rod surface elevation table, which measures vertical accretion or ground rising. You also need to measure the relative sea level. This comes from tide gauges. Lastly, correct both data sets for the slowly shifting bedrock by using GPS stations further inland. These measurements were collected across 227 individual locations over Louisiana's coastline. First, they split their measurements into two cases: the Mississippi Delta and the Cheniere Plain, or the western coastline of Louisiana. On the vertical axis, we have the rate of ground level rise, and on the bottom axis, we have the rate of sea level rise. If they perfectly match, then the data would follow the gray line. If the ground is sinking into the sea, then we'll be in the blue area. If the ground is rising out of the sea, then we'll be in the green area. Green is good, blue is bad, unless you want to live underwater. In the Mississippi Delta, 65% of the measurements are in the green, so most are not sinking into the ocean. Good. But alas, the story's a bit worse for western Louisiana. Here we only have 42% of the measurements in the green. Most are sinking into the ocean, so this would be bad. Now, the reasons for this difference between western Louisiana and Mississippi Delta are not directly proven by this dataset, but the authors do discuss some options, and I'll go through one of them. Mainly, it's a big reason, that being the Mississippi River. In the Mississippi Delta region, we have sea level rise, but the Mississippi River is also depositing more and more sediment onto the wetlands. This increase in ground level currently happens faster than the rate of sea level rise. In western Louisiana, we also have sea level rise, but no counteracting sediment. Thus, the ground is sinking into the ocean. There are likely more factors contributing to this difference, but I think the Mississippi River is by far the largest. Wrapping things up, in the Mississippi Delta, 35% of the coastline measurements show the land is sinking into the ocean. In western Louisiana, 58% of the coastline measurements show the land is sinking into the ocean. The question that remains for the residents of Louisiana, and specifically those of western Louisiana, is who will foot the bill when coastal homes and livelihoods sink into the ocean? On that note, I'll close this episode. Subscribe and share, and I will see you next time.